everyone, we're going to state why the integral is improper and evaluate the improper integral. From -1 to 4, we have dx divided by square root of absolute value of x. So the reason it's improper is that x cannot be 0, so we have infinite discontinuity x equals 0, meaning that our function is continuous on -1 to 0 or 0 to 4. So we have to write two different integrals here. And the way we're going to write that is take this integral. This will be integral I. So our two different integrals are going to be the integral from -1 to 0. And then that's going to be dx divided by square root of absolute value of x. Plus the limit, well, not the limit, let's not do the limit yet, plus the integral from 0 to 4 of dx divided by square root of absolute value of x. So let's get started. We're going to write this first part as the limit as b approaches 0 from the left, and then we're going to change our 0 to b. And we have -1 of dx divided by square root of -x plus the limit as b approaches 0 from the right. And now we're changing our 0 to be in the lower limit to 4 dx divided by square root of absolute value of x. All right, so the first part, we get the limit as b approaches 0 from the left. And if you evaluate this right here, this is going to be -2 square root of -x. And we're going from b to -1 plus the limit as b approaches 0 from the right. And this is going to be +2 square root of x. And we're going from b to 4. All right. Now, substituting in your b, when you substitute in b and go to 0, that's going to be 0. Just remember, this is like the 0 part. All right. And then when you substitute in -1, that's going to be minus for the -1, 2. So this is going to be -2. Square root of 1 is 1. You get -2. All right. And then you're going to have plus, and then substitute in the 4. That's going to give you 4 minus, and then for the b, that's just going to be 0. So we're going to get 2 plus 4 equals 6. And that will be your final answer. Therefore, this is convergent. And 6 is your answer. Thank you. Have a nice day. Bye-bye.